I think that we can start. Okay. I'm Davide. I'm from Solair. Solair is an Italian company that more than 3 years ago started building a platform, a cloud platform, in order to build IoT application. Okay, I was involved in the development of the embedded software part of our gateway, for example, or other industrial gateway that we used in our projects. And actually, I am project manager at Solair, so my purpose is to take a project from the start, from the requisite to the end and the final solution. What Solair does? Solair develops an IoT cloud platform that want to connect physical assets, so physical things, physical sensors, to company business. I mean that if you have data on your platform and you want to manage those data with your enterprise application, Solair is a good alternative for you. Okay, our technology stack want to take from one side data from sensors and from machines and things, what we call things, and bring those data to the cloud, to our platform. To do this, we develop a gateway, but we are open to all the solutions. So we have an image for the Raspberry Pi, or for example for the UDO board or other industrial gateway. And we built our embedded application on top of Eclipse Kura framework. This because Kura is a good choice to develop application in a very simple way, in an abstract layer, without access to the physical ports and the physical interfaces on your devices. And then I will show you how to manage with our blocks in a drag and drop way to build flexible IoT applications. Okay, our applications for the IoT starts from the manufacturing industry for example, machinery, but also we have projects in energy or smart cities. And the functionality that you can achieve with the platform starts from the predictive maintenance of the machines to the home automation or the performance management, for example. Okay, today I will show you a real end-to-end application for structural monitoring. There is a crack sensor that can monitor the linear displacement of a crack. So it can be used to monitor, for example, a tunnel or bridge when they are building, or for example, heritage historical monuments. So I will explain you the basic architecture of this project. We have the sensors, like the crack sensor, and the things that for us are the bridge or the buildings. And those data are retrieved by the gateway with a wireless interface, because the sensors are active RFD sensors. And then we bring those data to our platform, and we can manage those data in the enterprise applications that we can build with our platform. So the sensors are the Zeco crack sensor that is made by an Italian company. And it will communicate with a wireless RFD interface with the tag reader that is under the table, and is directly connected with the USB interface with our gateway. In the gateway, as I said, we developed our application on top of Eclipse Kura. And so we used the Java XCOM APIs, and we call the Solair HTTPS RESTful APIs to manage the data in the application. The purpose of this project is to monitor infrastructures and buildings' health with the linear displacement sensor, but also to detect abnormal structure movements like anomalies or, for example, disaster, and inform authorities and building owners. You can also analyze the data of the structural changes to improve the longevity and predict the maintenance cycles to your building or your infrastructure. Okay, we can start with the monitor, if the connection is okay. Okay. This is the login page of our application. So I am on cloud. The connection will be slow, but I should enter, okay. Now, what I want to show you is how to build the application on the Solair platform in a very simple way. And on the other side, how to take the data from the sensor with Eclipse Kura. So this is the dashboard of our application. These are only some links to entities of the application, or, for example, to a relative link. Okay, so we can start searching for sensors in our application. In this case, we have only one sensor. This one. Okay. 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 In this case, we can see some information about the sensor, so its ID or its displacement. Okay. We can set a start displacement. So when we start collecting data, we can set the start displacement, and so we can manage the variation of this displacement. But we have also information about the battery that is on board, because it's a wireless sensor. And we can change its configuration, for example, to set thresholds and give us information about critical alarms that can occur if the variation is too high. And in this way, we can see the last information about the sensor or the telemetry data. Like in this case, we have on the green the position, and on the red the temperature. And we can analyze those data to say if our structure or our building has a fail. Okay, we can, of course, go to the last 7 days of data, okay. But okay, we can see, for example, the location or something else about the sensor. We are in Toulouse. But other things are the relation between this entity and the other entities of the system. For example, the telemetry data that I show you in the property page, but I can see the table, for example, of the data. I can manage some attachments in my sensor, for example, the data sheet, okay? And I can show the data sheet directly on the cloud. I think it's too heavy for our connection today, but trust me. Okay, here we are. Okay, for example, the data sheet of the sensor and the reader. We can attach other documents. And we can see, for example, where it is installed. This is a relation that I made with another entity of the system. And this is a location entity, for example, that where we can find some information about the location details, okay, and my email, for example, or some other information. But I will show you how I made this application. Okay, if I go in the administration page, you can see some features of our platform. One is to make what we call the types. And the types are the main structure, the data model of our application. And we can have more than one application. For example, in this case, we have only one application, but I can build other application in the same tenant structure. Then I can model some workflows. For example, say to me that there is a critical event, and I want to inform the building owner or the authorities about these critical events. I will show you. Or we can build some reports. For example, I made a sample report about the Gecko sensor. This is only an example of the average variations of our sensors. In this case, I have only one sensor, but I can modify the graph according to the data pool of our entities. So coming back in the administration part, we have the integration tools that can manage a third-party system like CRM or ERP, for example. And okay, in this case, this is our types, okay? So we have configuration, location, document, the gateway type. We have some sensors as the Gecko that I bring here. But we can also see the data model. Okay, so we can see our types connected together. And I want to focus on the measure group types that are linked to the sensors. What we call the measure group are group of measures that the sensor will send to us and that we can manage, for example, in the property page that I show you. These are the data about the measure group that are linked to the Gecko type, for example. But also we can have configuration that we can update dynamically, okay, in our sensor and in our device. For example, changing the data interval or the sampling interval that the gateway pulls the data from the sensor, or for example changing some thresholds or some values of the sensors itself. For example, if I open the GECO part, I can show you how to extend, for example, our types, simply dragging and dropping what we call concepts. We have a library concepts, and it's more than 100 concepts actually. And we can take this concept from the library on the left. Okay. For example, a double concept or a string concept that are base concepts, but we have also some other concepts like scripting concepts or date concepts. Okay. For example, we can drag a double concept. Okay. I have the connection is not so good, but we should drag a concept here. So I build this type with using our library concepts, and in this case I cannot release because I think that I want to show you a concept on the grid. For example, a string concept. We can modify the concept, for example, in its label or in its advanced features, like if it can have a default value or a max length, for example. But we can also reference a cell of our spreadsheet. In this case, the spreadsheet is an advanced tool to take data from the linked types, or for example, to average a value or to calculate some percentage of the values or some modules, for example. So we have a tool to link the data between the types, so I can refer, for example, our measure group of the GECO and take by the timestamp in the descending order the first timestamp interval, or for example the first average value of the GECO position. Okay. So I can access to the data linked to this type, so the GECO, for example, the measure group, in a very simple way, using the cell of a spreadsheet. Okay. Now I want to show you, if I can, how I can change, for example, a threshold on our configuration on the GECO. In this case, I modeled the GECO type and the GECO configuration with some simple values. For example, then the type, we can choose the other tag, so the other sensors of the same manufacturer. Or we can change the sensor range, because this linear displacement is from 0 to 25 millimeters. Or we can change, for example, a threshold about the alert. This is particularly important because if we change this value and we update this value, the gateway will be informed about this change, and will send us events about this alert when the sensor overcomes the 12, for example, millimeters. How I can do this? Okay, if I open my bundle on Eclipse Kura, I will show you, for example, okay, in the sampling function that I will take the data from the sensors, in this case with a proprietary protocol that I implemented because it is very, very simple. And then after getting this data, if the data is overcoming our threshold, I will send an event. Sending an event to our platform is very simple because we can only have to create an event saying which kind of event it is and send the event using the Solair client. So in this case, we have developed a bundle in the Kura framework that you can use to develop our application in a very simple way, as I show you. For example, to send what we call the measure group. Okay. Okay, here. We can only create a new measure group, okay, like this, saying which type of measure group we want to create and the data interval that those data refers to. And we can send the measure group using the same Solair client that we create in the initialize procedure. In the initialize procedure, we create the Solair client saying only which server, in this case the production server, and in some other flags about the debug operation. And the gateway will inform our platform that he is the gateway with this MAC address and can communicate with us. If it was already allowed on our platform, it will receive information about, for example, the sampling rate or the data interval rate or the command interval rate or other stuff, for example, the threshold and the connected things, for example, these tags, and it can start to communicate with us. Okay. Coming back to the presentation. So, which are the results? Solair with Kura can integrate your sensors or standard sensors in a very fast way. For example, in this case, we used a serial protocol, but I took a few days to implement this protocol in Kura. But we can also change dynamically the configuration, as I show you, and extend our types, for example, dragging other concepts. And for example, if this sensor tomorrow is able to take also the pressure, we can only dragging and dropping another concept for the pressure and saying to Kura to take this new measure. So it's extremely dynamic. And also we reduce the time to market. This because we can make our application in few steps on the cloud, but also we can make it very simple with Kura. So we apologize some scenarios about the structural monitoring. For example, about the civil engineering, for the crack detection or the impact monitoring, and we can improve structural safety in this case, or detect damages with structures that are in service or are in building, and prevent the downtime and future disasters. Other applications are about smart buildings, for example, where we can integrate this data about the crack with the vibration data or the pressure data inside and outside the building. And in this case, we can analyze how the frame of the building changes, and in this case, improve the structural longevity. Another scenario is about the heritage building that is particularly important in Europe, for example, and we can monitor cracks and the humidity of our heritage building to optimize the long-time restoration planning, or, for example, to have an accurate picture of the structural properties of our buildings. This can build, as I show you, in a non-intrusive monitoring with these sensors, and we can have a measurement of environment variables in real time, every time using our cloud platform. So, I think that we have only a few minutes. If you want to join us, think of an IoT business application. Write an email to our developers account, developers@solair.com, solarcorporate.com, sorry, and email us about your idea, about the functionalities of your idea and the number of connected objects that you want to bring to your application. And then, if your idea is particularly interesting, we ask you to write a blog post on our blog describing your application, and we will take you a tenant to prototype your application and to bring this application in very few months to a business area. So, thank you for your interest, and if you have a question, I am here, and I will be glad to answer your question.
I have a question.
Okay.
I never worked with Kura before, and I didn't really understand what did it do really, what kind of
Okay.
did it bring you?
Okay.
This piece of code, what I saw is that you completely manually
Yes, there was only a few minutes, so, but Kura is a framework that is developed on top of the Java OSGi Equinox project, and you can build your bundles, your application bundles, and, for example, I will show you better. In this case, we have this. Okay, I have some code that I show you. Okay, about the initialization of the bundle, the activate method and the deactivate method, or the updated method, that are called from the container itself of the OSGi. And you can, for example, connect to your device and install these bundles in your device. I can show you, if I know the.
When you say your device, that's your gateway, right?
Yeah, our gateway, but you can prototype your application with a Raspberry Pi, for example. In the website of the Eclipse Kura community, you can download the image for the Raspberry Pi and start from the scratch.
It must be ARM, right?
Sorry?
It must be ARM processor, right?
Yeah, it is an ARM processor. In this case, we have I think that now Kura is compatible with Raspberry Pi, the BeagleBone, the Intel Edison, for example, in the last release. And you can, it's an open source project, so you can download the source code and compile from yourself if you have another architecture. Other questions? Nothing. Okay, thank you.